In the previous video, we have seen what is the issue with future and how completable future will solve the problem. Let's actually create a completable future in this session. But pay attention here because this is where most production issues begin. Because most developers use then apply everywhere even when they should not. And that creates one of the most confusing problem in async code, like nested features. In this video, I will show you difference between thenApply, thenCompose, and once you understand this, your async code becomes clean. Look at this code here, supply async, which takes a supplier, it runs your task asynchronously and returns a completable feature. So here, supply async will return completable feature. And this does not run on your main thread, it runs on a thread pool. Now compare this line, run async. It is used when you don't need a return value. So here we are not expecting any return. So it is void method. Like it will not give any return value. And this is extremely useful in real systems. When you already have the result but want to continue with the pipeline, you can use the completed feature. And if you see here, we are using failed feature, which is useful for testing and error flows. Now, this is where most developers make mistakes. Look at this line again. We used supply async. Which thread pool is this using? We already discussed which is running on separate thread pool. But what is that thread pool? By default, it uses fork join pool, which is a common pool. If you see this block diagram, this pool is designed for CPU work. It is having fixed size and it is based on your number of cores. Now imagine this, you run database queries here or HTTP calls. These operations can block. So what happens? Threads are occupied, no threads left for CPU work. This is called thread starvation and it's a real production issue. So look at this code now. This is the correct way to implement. You control the thread pool and you can separate concerns. Use different pools for database calls, HTTP calls or CPU work. Now look at this code. In modern Java, from Java 21, we use virtual threads. Now this changes everything. With virtual threads, each task gets its own thread. Even if it blocks, it doesn't block the system. Thread pool choice defines your system performance, not your business logic. Look at this diagram. These are virtual threads. You can have thousands of them, but they don't map one-to-one to CPU threads. Instead, they are scheduled onto a smaller number of real threads. Now here is the key part. When a virtual thread blocks, it gets unmounted. The carrier thread is freed. And that carrier thread starts executing another task. So blocking no longer wastes thread, it just passes the virtual thread. In traditional thread pools, blocking thread wasted. In virtual threads, blocking thread reused. If you remember just this, never use common pool for IO. Always pass your own executor. Now that we know how to create features, let's see what we can do with the result. Because this is where pipeline becomes powerful. Now we'll see how to transform the result. Now that we know how to create a completable feature, let's see what we actually do with the result. Because this is where most confusion happens. There are three main transformation methods, which is thenApply, thenAccept, thenRun. At first, they look similar, but they are not. Let's simplify them. Look at this code carefully. Here, input is user object, but output is string. So, thenApply takes a value which transform it, returns a new value. So, thenApply, it is just like a map in streams. Now, can you read this? It is like a pipeline. From user object, it is returning the name. And next it is applying the uppercase. Using the uppercase name, we are creating the greeting. So here each step transform the previous result. Now we'll see thenAccept. There is no written value here. It is just consumes the result. thenAccept is like a consumer. Now we'll see the third one, thenRun. If you see here, there is no input. It doesn't even take the result. It just runs something. thenRun is just a runnable. So now you understood, right? thenApply, which can use for transform the object. thenAccept, which can consumes. thenRun, which ignores. Now look at this code. thenApply async. This looks similar, but it changes everything. Without async, runs on the same thread that completed previous step. With async, runs on a different thread. So what is the difference between thenApply and thenApply async? Without async, runs on the same thread that completed previous step. With async, runs on a different thread from given executor. Now you can understand what we are talking. Step 1, which runs on DB pool, right? When you use supply async, which runs on DB pool. Step 2, when you use thenApply, which can runs on the same thread. Step 3, if you use thenApply async, then it runs on a different pool. If step 2 does heavy work, it blocks the same thread. That can slow down your system. Use async variants when you have next step is IO heavy or you want to control over thread. So completable future is not just about async, it is about controlling where work runs. Now we are ready for the most confusing part, thenApply versus thenCompose. This is where many developers get it wrong. Now we'll see what is thenApply and what is thenCompose. They look similar, but they solve different problems. So can you look at this code carefully? Here the return type is completable future of completable future, which is returning the nested list. Now to get the result, you would need to get deep, which is ugly and confusing and introduces a blocking. So basically thenApply will wraps the result. So now the solution is you can use thenCompose. No nesting, it flattens the structure. So basically thenCompose will flattens the result. If you know streams, thenApply is like a map, thenCompose will be like a flat map. So in a real production flow, if you see this code, now read this like a story. First we are fetching the user, then fetch orders for that user, and then build the response. No blocking, no nesting, clean pipeline. So decision is simple. If next step returns a normal value, use thenApply. If next steps returns a completable future, then use thenCompose. So thenApply transforms your values, thenCompose chains async operation. So many developers use thenApply everywhere, even when calling async APIs. That leads to nested futures, hidden blocking, messy code. Now you know how to chain async operations correctly, but real systems don't just run one call. They run multiple calls in parallel. Users, orders, preferences, all at the same time. So the next question is, how do we combine them efficiently? In the next video, I will show you how to make your APIs up to 3 times faster. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.